We are looking at quadratic equations. So important for grade 12 as well. This is the algebra section that you're going to have to revise in grade 12. Okay. This section is all about refreshing your memory on your quadratic equations. Now, if we look at this concept map, it might be like, whoa, it might seem like a lot. So let's just work through it together that you know exactly what to expect from this section. And if you can visualize this, everything that you need to know in this section will be on this page. I'll put a link in the description to some notes that also includes this concept map, and you'll also find a worksheet where all the sums that we'll be working through to revise your quadratic equations in this section will be in that worksheet. Okay, work through this with me. It is important to get a bigger picture of what we're dealing with and what is going on. Let's start on the left. No, actually, let's start over here. Why did I put exponential equation randomly in the middle of nowhere over there? Because our exponential equations is not part of our quadratic equation, so I didn't do that and connecting them. I'm just putting that as a reminder over there that other equations that we need to solve in grade 11 is also exponential equations, but it doesn't fall under this section. So we'll get to that under the exponent section. Now, on the left there, solving for quadratic equations. Our quadratic equations is always in this form, and there are different ways that they can ask you to solve it. Well, normally if they just say solve for x, you always go see if there are factors. You factorize it, right? When you put it into your brackets, and most of you use your calculators for this. Then if you can't use your calculator, in other words, you can't put your quadratic equations into those factors, then you're going to have to use the quadratic formula. This guy over here that is normally on your formula sheet. No, it should be on your formula sheet. And then often we get our answers in third form or with decimals or something like that. And then they can ask you explicitly to solve for x by completing the square. Then that's the only method you can use. Then you can't use the formula or factorizing. So there's just a little reminder of how that works. Our a value needs to be 1, and this is that example where we take our b value and we divide it by 2 and we square it. I find normally when I show students that step, they're like, oh yeah, that's what completing the square is. Anyway, there is an example in this section that makes sense of completing the square with you again, and there's also some videos on what is completing the square if you're interested in that at all. Okay, now what is going on the right hand side over there? This is how I make sense of it. So I often hear my students say, but I don't know how to start this sum when it looks a certain way and I can't figure out how to start. So I just made a little note there. You need to know how to spot almost like the form in which they give it to know exactly how to start. And then if you can start correctly, normally you just end up with a good old trinomial again, and then you factorize it or you use the quadratic formula and you solve for x. So over there, they give you equations with fractions. The moment that you see equations with fractions, in your mind you need to think, I need to find the LCD, and I need to consider that there are restrictions. So when you see equations with fractions, immediately, once you found the LCD, I find that then students are okay and they are well away and don't lose marks for not stating your restrictions. Then, with simultaneous equations, obviously that is when they give you more than one equation, and then they are in terms of two different variables. So it can be x and y, or it can be m and p, or it can be a and b, or whatever, but there are two different variables that we need to solve in two different equations. How do we do that again? We're going to choose one of those equations. I chose the first one, and you isolate one of the variables. I decided to isolate my x, and once we've isolated our x from the first, we're going to substitute that into the second one. Have a look at that video when we do an example like that. Word problems. Oh, everybody's favorite. It's all about reading carefully. I just laugh at my students like, okay, explain the scenario back to me. Then they can't. The only thing they can remember is the values. They can only tell me there was something about 20 kilometers per hour and then 5 hours was the time. But they can't put themselves into the context of what is going on with this word sum and think logically and practically about it. Make sure that you read it carefully. You need to read it 3 times at least. And then we're going to draw a table together. It just makes your life so much easier when you put the information in a table to make sense of that. And then students want to try and play around in their calculators and figure out the answer like that. No. With the word sums, the whole purpose is to build an equation with the information. Then with some surd equations, they are those equations where you have a square root when you start out with your equations. Then you just need to remember, I need to isolate my square root. What does it mean? You need to get your square root alone on one side of the equation. Then you need to square both sides of the equation because that will make the square root go away. And then you need to remember to test your solutions. These sums are often like 5, 6 marks, and we don't want to lose marks for something like that. And don't worry, head over to that section where we do an example like this together clearly. These are all just little hints to jog our memory of what a surd equation is and what simultaneous equations is. So when you look at this mind map, you can just remember, oh yeah, that one looks like that, that one looks like that. Okay. And then for our inequalities, oh my goodness, I don't know why students don't take these seriously. But this is where we're going to make a little diagram to help us figure out where the solutions for X are. K method, students often find this very difficult, and that's okay, but I feel like once you've seen it, you can't unsee it, and the students are actually pretty good with it. So if you get a sum like this one over here, when you see the equations with fractions, students go get the LCD, and then they land up with something like x to the power of 4, and then they just like, I don't know what's going on, and then they give up. So with something like this, when we also have I would call it not a complicated denominator, but when we've got something that repeats, do you see from that sum, the 2x squared minus x is repeated over there, 2x squared minus x. Then we let that thing that repeats be equal to k. And then we solve for k, and then we'll bring back x later. So it's when we got something quite complicated like that, we're going to land up with x to the power of 4 when we try and make the denominators the same and things like that. We rather go for the k method. Then nature of roots. This is a section where I find that they quite like asking some problem solving questions. So there's so much more to it than just remember these little delta is smaller than 0 and what it means. We need to interpret these sum in detail. So we're going to do a few of those. So what is delta? Delta is equal to b squared minus 4ac. Where have you seen that? It is what is underneath the square root in our quadratic formula. And the nature of roots are, it tells us what are the roots of an equation like? What are the solutions of an equation like? Are they real? Are they non-real? Are they equal? We need to comment on what the roots are like. And what is underneath that square root tells us what the roots would be like. So then we need to know if my delta lands up being smaller than 0, so we get a negative, the roots will be non-real. Why? Because we cannot get a negative under a square root. Then if my delta is bigger than 0, I know that my roots will exist. They will be real. And then if my delta is equal to 0, then the roots will be equal. So we'll dive into that in a little bit greater detail for nature of roots. Let's jump in and look at each of these and do an example of each of these. And then at the end, there will be a challenge section just with a couple of questions on some higher order thinking questions that can show up under the equation section. Like I said, the links to notes and the worksheet is in the description below. I'll see you in the next video.